Hello, this is Dr. Hanaa Assil, and this is paper 2C of the Pearson Edexcel IGCSE Chemistry. This was the paper in June 2018. So let's take a look at the questions and discuss the answers. So the first question says the diagram shows a Bunsen burner. The Bunsen burner uses methane as a fuel. Methane has this formula. Give the names of two elements in methane. Of course, this is the formula of methane. The elements in methane are carbon and hydrogen. Now, when methane burns, it reacts with a gas in the air. Give the name of this gas. When anything burns, it reacts with oxygen. So when we say burning or combustion, that is reaction with oxygen in the air. Name the two substances that form when methane burns in plenty of air. I'm going to remind you that we have two types of combustion or two types of burning. If we have complete combustion, this is the reaction in presence of plenty of air or a lot of oxygen, and the incomplete combustion is the one in which we have lack of oxygen. So when methane or any organic compound burns in a lot of oxygen, then the two substances that form are carbon dioxide and water. But when we have incomplete combustion, or burning in shortage of air or in lack of oxygen, then the poisonous gas that forms is carbon monoxide. A student uses this apparatus to investigate the burning of 4 different liquid fuels, W, X, Y, and Z. So he is bringing a copper can with some water in it, and he has different fuels, and he's going to use them to heat the water. And then he's measuring initial temperature and final temperature. And the first question says, complete the table by giving the increase in temperature for the fuels. Of course, increase in temperature is just the difference between final and initial. So final minus initial gives these values. So this is just subtracting the two values from each other. The student uses some same mass of water and burns each fuel for the same period of time. Explain which fuel releases the most heat energy. So this was the table that we had. He used the same mass of water and he burns each fuel for the same period of time. Now, which fuel released the most energy? Of course, the one that released the most energy is the one that caused the highest increase in temperature. So which one caused the highest increase in temperature? So that is fuel. Why? Because it caused the highest rise in temperature. What is the name given to reactions that release heat or release energy? Reactions that give out heat are called exothermic. A student makes an alkali solution by dissolving a small volume of cleaning liquid in deionized water. Of course, deionized water is distilled water or pure water. He then titrates a sample of this solution with an acid until neutralization is complete. So what did he do? He makes an alkali solution by dissolving a small volume of cleaning liquid in water. So he has a solution of cleaning liquid, and he says this is an alkali, so this is a basic solution. And then he titrates it with an acid. The diagram shows the burette readings for his titration. Use the readings to complete the table. Of course, when you read the values from a burette, the burette is starting 0 at the top, and then it increases as we go down. So the burette reading after, can you see which one is after? After is the one on the right. He already read it for you. you read it from the small number to the big number. So this is 20 point something, not 21 point something. So this is 20.8. And he says, read to the nearest 0.05. So what is the reading before? Obviously, the reading before is 3.1, and then we're in between 3.1 and 3.2, so this is 3.15. The volume of acid added would be the difference between them, so that is 17.65. Another student does a titration using a solution of different cleaning liquid, and he got these results, or she got these results. Concordant results are those that differ by 0.2 or less. So, place ticks in the table to show which results are concordant. Again, I'm going to remind you, when we do titration, we don't do it just once. We do it several times, 2, 3, 4 times, until we get concordant results. And that means I get results that are within 0.2 centimeter cubed of each other. So which of these are concordant? The difference between them has to be 0.2 or less. So the one that says 26 point something is way off. So that is wrong. So I am looking at the ones that say 25 point something. So the ones that are concordant are these three. If you look at them, the difference between each two of them is 0.2 or less. Okay. And then once we have decided which ones are concordant, these are the ones that we use to get the average. So when he says calculate the average volume of acid added, you use the concordant results, not all the results. So these three results, average means you add them and divide by their number. So these are three results, you divide by 3, and that means my average volume of acid is this. Okay? Question 4 is talking about bromine, chlorine, fluorine, iodine, which are elements in group 7 of the periodic table. And he's saying which element is the most reactive. I'm going to remind you again. These are group 7, fluorine, chlorine, bromine, iodine, astatine. Now, which one is most reactive? Remember, in group 7, the one on top is most reactive. And this is opposite to group 1. We said in group 1, these are metals. The one down is most reactive. But in group 7, the one on top is the most reactive. So fluorine is most reactive. So when he says which element is most reactive, it's fluorine. Remember that in the group 7, as we go down, the density increases and the color gets darker. So as we go down, fluorine, chlorine, bromine, iodine, astatine, if we're talking about the state, gas, liquid, solid. If we're talking about color, the color gets darker. Yellow, green, reddish brown, liquid. Remember that bromine, again, remember that bromine is the only liquid, non-metal. Okay, so the first question says which element is most reactive? We said the one on top, fluorine. Which element is a solid out of these choices? Remember, iodine and astatine below it are the solids in group 7. Which element has the darkest color? Again, as we go down, the color gets darker. So out of my choices, iodine has. Okay, then he says bromine reacts with hydrogen to form hydrogen bromide, and he gives me the equation. The table shows some average bond energies. Use the values to calculate the enthalpy change. So we're trying to calculate delta H for this reaction. Of course, when we have bond energies, what we do is we have these bonds. Remember that we're looking at the bonds and not the number of atoms. So we have one HH bond, and that is 436. One BR bond, so that is 193. And remember, it is reactants minus products. So the products here are 2 HBr bonds. Each of them is for 366. So reactants minus products, you get a delta H of minus 103. Remember, delta H must have a sign. Ethanol can be manufactured by fermentation or by direct hydration of ethene. In Brazil, the main source of sugar for fermentation is sugarcane. Sugarcane is added to water, and then sugarcane contains sucrose. This dissolves in water. During the fermentation process, the sucrose is broken down into glucose. This glucose is then converted into ethanol and carbon dioxide. And the first question is, name the substance that is added to sucrose to allow fermentation to take place. When we have a sugar solution and we wanted to do fermentation, what do we add to the sugar solution? We add yeast. Complete the equation for conversion of sucrose into glucose. He already tells me that the C12H22O11, that is sucrose. And when we add water, it should give glucose. Glucose is C6H12O6, and to balance, we need a 2 in front of that. Write a chemical equation for the conversion of glucose into ethanol and carbon dioxide. Again, chemical equation means symbol balanced. So, we're starting here with glucose. It gives ethanol. This is how we write ethanol, C2H5OH, plus carbon dioxide. And you will find that in order to balance, you need to put a 2 in front of ethanol and 2 in front of CO2. Please remember how to balance. You count the number of elements before the arrow and the number after the arrow, and you increase the one that is less. Okay? So before the arrow here, we have, let's start with hydrogens, for example. We have 12 hydrogens. Now, after the arrow, we have hydrogens in the ethanol. Each ethanol has 6, so I need 2 in front of the ethanol to have 12 hydrogens. Before the arrow, I have 6 carbons. Now, once we put 2 in front of the ethanol, that's 4, so we need 2 more. We put it in front of the CO2. Now we count the oxygens. Remember, leave the oxygens till the end. We have 6 oxygens before the arrow. How many oxygens do we have after the arrow? We have 2 in ethanol and 4 in the 2 CO2s. So 4 plus 2, that's 6. So this is balanced. Fermentation produces a solution that is a mixture of ethanol and water. Which of these is the most effective method of obtaining ethanol from a mixture of ethanol and water? Remember, ethanol and water is a mixture of liquids. How do we separate a mixture of liquids? We use fractional distillation, not simple. Remember, we use simple distillation if I have just a solution and I want the water. But if I have a mixture of liquids, then we separate them using fractional distillation. In the direct hydration method, ethene reacts with steam. Name the catalyst. Remember, this is the other method of making ethanol, where we start with ethene, add steam. What were the conditions? You have to remember the conditions. So the catalyst is phosphoric acid catalyst. The temperature is 300 degrees Celsius and the pressure is 60 to 70 atm. Please remember these conditions. These are the conditions for addition of steam to ethene. This apparatus is used to convert ethanol into ethene. So this is the opposite. Now I'm starting with ethanol and I want to change it to ethene. This type of reaction is dehydration. If I'm trying to remove water from the ethanol in order to change it into ethene, this is dehydration. What are the conditions for dehydration? We need the aluminum oxide to act as catalyst. Remember, in dehydration, what is happening is we're changing ethanol to ethene. What are the conditions? We said we use aluminum oxide catalyst and heat. Ethene belongs to a homologous series of unsaturated hydrocarbons called alkenes. State what is meant by the term unsaturated. When we say alkenes are unsaturated, that is because it has C double bond C. Alkanes that have no C double bond C are called saturated. Then he says, state the color change that is observed when bromine water is shaken with ethene. Remember, what was the test for ethene? We said add bromine water. It turns from orange to colorless. Phosgene is used in industry to make polymers. Phosgene is formed when carbon monoxide reacts with chlorine. The reaction mixture is kept at temperatures between 50 and 150. If a temperature above 200 degrees Celsius is used, only a small amount of phosgene is formed. Suggests why only a small amount of phosgene is formed at high temperature. Remember, this is an equilibrium reaction. If I increase the temperature, we said increasing the temperature causes the equilibrium to shift to which side? Increasing the temperature goes endo. So, looking at this reaction, is this endo or exo? The forward has a delta H that is negative. That means the forward reaction is exothermic. So at high temperatures, the equilibrium for this reaction will shift to the left because this is where we have endo. So less product of COCl2 is formed. Remember, in a reversible reaction at equilibrium, increasing the temperature causes the equilibrium to shift to the side that is endothermic. So in this case, it's backward or to the left. Predict how the yield of phosgene will change if the reaction is carried out at higher pressure. Okay, this was the reaction again. Now, when we increase the pressure, what happens to the point of equilibrium? We said increasing the pressure causes the reaction to go to the side with less number of moles. We're not looking here for endo or exo. Remember, we look for endo or exo only when we're changing temperature. When we're increasing pressure, it goes to the side with less number of moles. So in this reaction at higher pressure, the equilibrium will shift to the right or it will go forward because this is where I have less number of moles or less number of molecules, and that means it will give me more yield of phosgene. Phosgene reacts with water to form hydrochloric acid and carbon dioxide. Write a chemical equation. Again, he already gives me the formula of phosgene, COCl2. And you're reacting it with water, and he tells me it gives hydrochloric acid plus carbon dioxide. We need to balance. Now, how many carbons before the arrow? We have 1. How many carbons after the arrow? I have 1. How many oxygens before the arrow? 2. How many oxygens after the arrow? I have 2. How many chlorines before the arrow? I have 2 chlorines, so I need to put 2 here, and that means now I have 2 hydrogens and 2 chlorines, so now it is balanced. The diagram shows the displayed formula of phosgene. Draw a dot and cross diagram to show the arrangement of the outer electrons in a molecule of phosgene. Again, how do we draw dot and cross? We said the oxygen, for example, let's start with the oxygen. Oxygen is in group 6. That means it has 6 electrons in its outermost shell. So it needs how many? It needs 2. That's why it's making a double bond. And a double bond between the carbon and the oxygen means 2 electrons from the carbon and 2 electrons from the oxygen are being shared. Please do not forget the extra electrons that are not involved in sharing. So if oxygen has 6 electrons in its outer shell, it's using only 2 of them. So I have 4 electrons left around the oxygen. Now, each chlorine is in group 7. It has 7 electrons, so it needs 1 from the carbon. And it still has the rest of the 7 of electrons in the outer shell around the chlorine. Do not forget the electrons around each chlorine and the electrons around the oxygen. Magnesium carbonate decomposes when heated to form magnesium oxide and carbon dioxide, and he gives me the equation. A student uses this method to investigate the reaction. Weigh a clean, dry crucible, record the mass, add some magnesium carbonate to the crucible and reweigh, record the new mass. So he's just weighing the magnesium carbonate in a crucible. Heat the crucible and contents for 5 minutes. Allow the crucible and contents to cool. Reweigh. Repeat until the mass does not change. So he's trying to heat the magnesium carbonate so that it breaks down and gives magnesium oxide plus carbon dioxide. How do I know if the reaction has finished? If the mass does not change anymore. Of course, when we're heating magnesium carbonate, the mass should decrease because it's giving out carbon dioxide and the gas escapes. And then when the reaction is over, then there is no more decrease in mass, then you know that the reaction has finished. The student does the experiment 4 times and the table shows her results. State why, first of all, state why the mass of the crucible is decreasing during heating. Again, we're saying, what is he doing? He's heating the magnesium carbonate. This gives out carbon dioxide gas that escapes. So the fact that the carbon dioxide gas escapes, this is why the mass is decreasing as he repeats it. So mass of crucible for a total of 10 minutes, mass of crucible for a total of 15 minutes, and so on, they are decreasing. State the reason for step 6. What was step 6? Step 6 says repeat the steps 4 and 5 until the mass of crucible and contents does not change. We said we keep heating, cooling, reweigh. Heating, cooling, reweigh until the mass does not change. Why are we doing that? To reach constant mass, to make sure that the reaction has finished. Explain in which experiment the student should have heated for a 4th period of 5 minutes. So we're supposed to, for each experiment, experiment 1, experiment 2, experiment 3, experiment 4, we should keep heating until what? We said until the mass does not change. But in experiment 1, okay, the mass is decreasing, but it is still decreasing. After 15 minutes, it's still decreasing, so he should have continued heating. In all the other experiments, after 10 minutes and after 15 minutes are the same results. So the mass has become constant. But in experiment 1, the mass is still decreasing. Acid digestion is caused by having too much hydrochloric acid in the stomach. A suspension of magnesium hydroxide in water can be used to cure acid indigestion. The equation for the reaction between magnesium hydroxide and hydrochloric acid is this. A student investigates how much magnesium hydroxide is needed to neutralize 100 centimeter cubed of hydrochloric acid with concentration this. He uses 0.29 grams of magnesium hydroxide. Calculate first the number of moles of HCl. How do we get number of moles? HCl is a solution. Number of moles is concentration times volume. What is the concentration? What's the volume? The concentration is 0.0968. The volume is 100 centimeter cubed, but we cannot put it as centimeter cubed into the equation. We have to divide by 1,000 so that it is 0.1 decimeter cubed, and that means the number of moles of HCl is 9.68 times 10 to the minus 3. Then he says, what would be the number of moles of magnesium hydroxide? Remember we said, he says 0.29 grams of magnesium hydroxide was put. So we're going to calculate the number of moles, mass over molecular mass. This gives me a certain number of moles of the magnesium hydroxide. Then he's asking, explain whether the student used the right amount of magnesium hydroxide to neutralize the hydrochloric acid. What was the equation? This was the equation. So according to the equation, the number of moles of HCl should be twice. Can you see that? The number of moles of HCl should be twice the number of moles of magnesium hydroxide. Now, what did he put? He put 5 times 10 to the minus 3 of magnesium hydroxide and about 10 times 10 to the minus 3 of HCl. So is that correct or wrong? The number of moles of magnesium hydroxide that we need should be half that of HCl. So that is about 5 times 10 to the minus 3. So what he added was the right amount. Can you see that? It is the right amount if the ratio is correct according to the equation. The equation says the number of moles of magnesium hydroxide should be half that of HCl. It is about half that of HCl. This question talks about the manufacture of sulfuric acid. The equation for the reaction in step 2 is this. What does this symbol mean? Remember, this symbol in any equation means that the reaction is a reversible reaction. What does delta H mean? Please do not write delta H, D-E-L-T-A. We don't say this is, we call it delta H, but it represents what? It represents enthalpy change or heat change. Name the catalyst used. Remember, this was a reversible reaction to form sulfur trioxide. This was actually called contact process. The catalyst is vanadium pentoxide, and this reaction should be done at 450 degrees Celsius and a pressure of 2 atm. These are the most suitable conditions for this reaction. Using any temperature higher or lower would not be correct. Using a pressure that is higher would not be correct, and so on. We talked about this when we were talking about changing the conditions in a reversible reaction. Now, the rest of this is actually a part that has been cancelled from the syllabus, so we're not going to discuss it. This was in a previous syllabus and it was removed. So this is the end of this paper. I hope this was useful to you, and thank you for listening.